Okay, so let's have a look at the code. What we have here is code to get you started with this exercise. So it's pretty close to what you can see in the reading assignment. We have here a main function and a reader function. The reader function will operate on a file descriptor and a number. When you call the reader function, you're going to give it the file descriptor corresponding to a pipe from which the child process can read data, and n will correspond to the number of the child process. So in our example, we want to call this function twice, once with the parameter n equal to 1, child 1, reading from a given pipe end, and then a second time with n equal to child 2, reading from another pipe end. You can see here the code of the reader function. Okay, we have a buffer of 256 character maximum, so we can use that to actually read from the parent process the message that we need to display. Since those messages are just single words read by scanf, that should be more than enough. We have here the printf that indicate that a given child process is ready to read. You can see that we use for that first %d the value of n. Then we reopen the file descriptor, which is a low-level file descriptor, as a stream, a file star data structure, so that we can use things like fprintf, fscanf, etc. in it. We have here a loop, which I suggest you reuse as is if you're not familiar with that kind of file processing. We keep reading from that stream, which corresponds to the pipe, until what? While we don't encounter an end of file, while we don't encounter an error, and while we can successfully get a line of input from the buffer. Okay, so the fgetS function, type man space fgetS if you want more information, but it's going to store inside that buffer, which size is specified here to avoid overflow, whatever we can read from the stream until we meet a new line character. Then we display on the screen, prefixed by the number of the process n, we display this string that we just read on the screen. Okay, if this string is compared positively to by, then we exit the child process. So we use here strn compare, which is a string comparison function which operates only on the n first character. We do that so that we don't have to worry about the buffer here containing the string by plus a \n that would represent the enter key hit by the user. So we just compare the first three characters and we exit if they match by. Inside the code of the main, we have missing some code here. We are going to fill that in a minute, but right now we have two pipes declared. One is for communicating with child 1, the second for communicating with child 2. We are going to reopen those pipes as file stars so that we can use fprintf. So we have here already 1 and 2, which are 2 pointers on file data structure, which are going to correspond to the writing to ends of the pipe towards the child 1 and the pipe towards the child 2. This loop is an infinite loop. We display a prompt on the screen. We have another buffer here to read up to 255 characters as a word, a single word from the user, store it into the buffer. The 256 characters is for the \0 end of string marker. Then as soon as we read something from the user, we fprintf it into 1 and we fprintf it into true, followed by a \n. Okay, and we have flush to make sure that this is immediately sent. So this is how we are going to write to each child, write to the pipe for each child. However, right now 1 and 2 and pipe 1, pipe 2 are not open, created, whatever. So this is part of the code we'll have to do here between line 9 and 11. Then we sleep for 1 second just to pace the execution, and we compare our buffer to by. If it's equal to by, we break out of our loop. So this is how we get out of the loop. Once we are done, there will be some cleanup here to add to close actually the pipes. We wait for the first child process, whichever is going to exit first, and then we display the fact that one of our two children process has exited. We wait for the second, do the same, and then exit the parent. So really, there are only two spots in this code where we need to work. I suggest that you pause the video and get started with that. that should help you a long way already through this exercise, and try to come up with those initialization and cleanup code by yourself. Okay, we're going to resume the video here. So what do we have to do here to start initializing our pipes? Well, we have to use the pipe function. So we are going to start by initializing the first pipe, the pipe for child 1. So if pipe, and I'm getting here with pipe 1, okay, different than 0. So I'm checking that everything went okay. If there was a problem encountered, I handle this as we always handle problem, rudimentary. So I'm just saying unable to, whoops, with a little typo, unable to establish first pipe. And I'm going to exit with a return code, which is exit failure. That's for the first pipe. First pipe is there to talk to the first child. So I need to create that child now. So let me declare a variable of type PIDT named f1. And I'm going to store inside of it the result of calling a fork. We are used to that kind of stuff. So when you create a child process like that, it should become almost a boilerplate code now for you. You need to check if the fork actually worked. If not, unable to fork message on the screen, exit failure. What else? Well, if it's not lesser than 0 strict, it can be equal to 0. So if f1 equal 0, then that means that I am dealing with the child process. What do I need to do in the child process? Well, I'm going to have to execute the reader function at some point, that's for sure. I'm going to have also to set up my pipe 1 communication. What does it mean to set it up? Well, that means that the child, as you know, pipes are unidirectional. There are two ends in the pipe, pipe index 0, which is for reading, pipe index 1, which is for writing, and each of the parent and child process need to close one of those ends. A pipe is two file descriptors. The parent will use one, the child will use another, depending on what direction the communication goes. You cannot do both at the same time. So here, that means that the child process will read from the parent. So I can close safely the end of the pipe for that parent-child communication, which correspond to writing to the parent. Then I can call reader, and the file descriptor I'm going to use will be pipe 1 index 0, which is an end that allows me to read from my parent. And I'm going to say the number of that child is 1. Then I'm going to close pipe 2 index, pipe 1 index 0, once I am done with the reader function. And I'm going to exit with, well, everything went fine if I reached that point, exit success. That's the code for the child. What is the parent going to do? Well, the parent is not done. The parent needs to, well, clean up pipe 1 index 0. And by clean up, really what I mean here is close its end of the pipe, the end that we are not going to use, the end that allows us to read from the child. So we are not going to read from the child, we are going to write to the child. And to do so, we have to reopen, since we want to be able to use printf, we want to reopen the pipe 1 index 1 descriptor as a file star. So we use the fdopen function here. Once we are done, as usual, we need to check that everything went okay. If I get null out of this call to fdopen, that means that something didn't work. P error, unable to reopen a file descriptor number 1. That should be enough description. Exit failure. Okay, so if we are done with that, then the next step, what is it? Do the same thing for child number 2. So I'm going to do a cut and paste for that part. Let's go right here. This is where we start forking child number 1. I'm going to come here, cut and paste, and I'm going to adapt. So this is child number 2. Okay, F2, we use pipe number 2 to communicate. The number of the child will be 2. The parent will close its end of pipe 2, and we are going to reopen pipe 2 index 1 and use the variable 2 as file handle on that guy. And of course, when we test if there was a problem, we need to test 2 instead of 1. Unable to reopen file descriptor number 2 will be the error message that we display. Okay, we are done with the initialization. Now what about the cleanup? Well, the cleanup here is going to be executed by the parent process. So we used pipe 1 index 1, which we are going to close like so. Pipe 1 index, pipe 2, sorry. Pipe 2 index 1 is going to be the second pipe that we open, and we're going to close here before to wait for our children process and to exit. So let's have a look at how this compiles first. So we're going to open Conqueror here. Let's clear up that mess a little, and we are going to gcc a04.c a.out. Unable to reopen file descriptor number 2 byte file descriptor. Well, let's have a look at the code here. Unable to reopen file descriptor number 2. We have here pipe 2 index 1, pipe 1 index 2. Let me see here what we have. Okay, the only thing I can see missing here is the initialization of the pipe, which is done right here and which I didn't include in my cut and paste. So this is what the problem here is here. So let's grab this, let's go here. This time we initialize our pipe. We initialize pipe 2, and we're going to say enable to establish second pipe. Let's save and let's recompile and retest again. So we're going to recompile, run it again. Child 1 is ready to read, child 2 is ready to read. Let's type something like 1. Take out the message. We have a little sleep in the parent to give us time to display the output from the children before to prompt again the user for something more to work. Now let's try buy. If I type a buy, child 1 is exiting, child 2 is exiting, the parent is waiting for them before to exit. So this code here actually solve the exercise.